Hey everyone, welcome back to the channel. Today we are going to continue with the machine learning series. I am going to explain you today what is linear regression using the mathematical equation. I understand at a beginner level, every beginner wants to implement the data set using real-time data set using Python, right? Because you want to implement, you want to get a practical experience, you want to gain it so you can build your strong job portfolio. So this is totally fine. It's a part of your, like a mandatory part of your AI journey too. But if you don't understand the mathematical or statistical reason behind the machine learning algorithm, then you may stuck in real time world. So this is very important. Mathematical behind each and every machine learning algorithm is the mandatory skills. Without knowing your mathematical equation or the logic behind the machine learning algorithm is not going to help you to become an expert in AI. Python is just the like that programming tool. You use it using its inbuilt methods and the libraries to implement it for the machine learning, because we need to convert the data into the code actually, so our machine can understand and train the model. Believe me, if once you spend the time to learn the logic mathematically behind the machine learning algorithm, you will never stuck in the real time. You will become expert in AI because you can easily implement using Python, because this is going to be easy for you. uh, the reason, you have already understood the process of machine learning life cycle, and you know the logic how it is going to work your algorithm behind the picture, and it will help you to like build a strong model. This is very important, believe me. So spend your time at initial level about on the mathematical your logics too. So I in my previous videos I have already explained what is regression, and different type of models come under the regression. Today we are going to continue with the mathematical part. So let me open my whiteboard. Here we go. So let's start with the linear regression equation mathematically. Okay. So what is your linear regression? Linear regression. Okay. The equation for linear regression is your y is equals to mx plus b. Okay. So this is the formula of your linear regression model. And your model can be like using one variable or multiple variable. I will tell you the difference. Okay. So first let's understand what is linear regression. Linear regression means when it is a statistical method used to like check the relationship or build the relationship between the two features. It can be one feature or other will be the target feature. It can be multiple features with the target feature. So now first let's understand here this one. So let's say I am picking up the real time data set. This is a house sale price. So let's say you have the number of rooms and price of the house. If 2 or 3 is the number of the room, 200K, 300K is the price. So this means you can see here, this is the price and this is the room. You want to predict the house sale price based on the rooms, right? You have collected the data of your houses from of your city. And now your goal is to predict the house sale price based on the given features. Okay. So this is called linear regression. And when this is in this term in your machine learning world, what you want to predict, what you want to predict, this is called denoted by y. It can be caps or small, it doesn't matter, we can use it here caps. We also call it dependent feature, which you want to predict, or target feature. Okay. And the here, this is called x. This is the one. So this is called independent feature, using which you want to predict your value, independent features. because number of rooms doesn't like dependent on your price. This is individual, right? But your price is depend on your number of rooms, because number of room is going to decide the price of your house. So it is denoted by X in machine learning world, and it is denoted by Y. Now you know what is Y, what is X. So now we will move ahead with the M. M is nothing, this is just the slope of the line. Okay. It is also like tell you how your Y, how your predicted value will be affected when there is a change in the X. Now look at this. If the number of room are 2, the price is 200K. If the number of rooms are increasing, the price is also increasing. So this is called slope of the line. If I show you on the graph, it will look like this. This is your X, this is your Y, and this is your number of rooms, and this is the price. If the number of rooms increasing, price will also increase. Let's say this is a slope, this is a line. So this means this changes in this, your X is affecting this one, your Y. Okay. And this is called M, this one. This is your M. We also call it trend line, regression line, okay, or slope of the line. Okay. And then we will talk about B. B is the intercept value. This is the most important part, and this is like you can say value of the Y when X is equals to 0. Okay. And this is the just definition of your linear regression, and what is your Y, what is independent feature, what is dependent feature, what is a slope, and what is intercept. Using this equation, we are going to move ahead to calculate the linear regression line. This is the one. This is because when we are talking about the regression models, your goal is to draw this line. Okay. And how you are going to draw this line? Using this formula. And it is not mandatory. This line will be like in this direction. It can be like this. Okay. It can be like this. Okay. This is like with the single variable we are talking about right now, but it can be with the multiple variables too. Okay. If you want to know at a deeper level, you can watch my previous video too. You will, it will make you understand. Okay. Now I will clear this page. We will moving ahead with the same example. So we will take the same example of house sale price, but I want to draw one graph for your better understanding. Okay. Sorry, table. So here we have the table. So in this table, first column is number of rooms again. So this is denoted by X because it is an independent feature, right? So number of rooms are this one. Now we will draw here price of the house, and it is denoted by your Y. Let's say $200K, $300K, and this is your mean of X. I will tell you why we are making this table. Okay. So mean is nothing. Mean of X is nothing. It is just average of your this column. If you want to take a deep dive, you can watch my statistics playlist. I will show you at the end of the video too, where you can learn about the statistics from the start. So 3 plus 2 divided by 2 is going to be 2.5. This is the mean value of your X. Okay. And now we will calculate the mean value of Y2. Same formula we are going to apply. Addition of these two numbers divided by 2, because the total number of data points is 2. So it is going to be 250. And then we have deviation from X. Standard deviation of X. It is nothing. This means whatever value of the mean, how your other data, your data points are deviated from the mean value, the X data points. If I show you here on the graph, it is like this. So this is a bell curve shaped. Okay. Bell curve, we call it normal or Gaussian. your distribution 2, okay? And these are your mean. This is a, let's say this is a mean, and this value is 2.5. Now I want to calculate the standard deviation of x. So this means I want to know how much, at what point, or how much unit it is deviated from your mean to this point, okay? So what we will do here, you need to do x minus mean. So what will be the value? 2.5 minus, sorry, 2 minus 2.5. So the value will be minus 0.5. And for the next is 0.5. And same you need to calculate the deviation of y. I will tell you why we are calculating it, okay? So it is minus 50 and the next one is 50. The next column is product of the deviation. Standard deviation, okay? And the value of your first case is 25 and this is also 25. The product of these two values, okay? So we are doing here xy, okay? The next is your sum of the deviation. Sum of standard deviation. So this is going to be 50. You only need to do addition of this, okay? So this is going to be 50. Now you need to calculate the square of standard deviation 2. X, okay? Only x. So this is going to be 25 and 25. How? We are just taking the standard deviation. Standard deviation of this is 0.0 multiplied by 0.05. 25. This is also 25. Okay. Now I will tell you why I made this table and why you need it. We will write the equation here again. Mx plus b. So whenever we are talking about the linear regression model, this work based on the least square method. Just fit in your mind, least square method formula we are going to apply to find the slope of your line, okay? So I will remove this, okay? And then I will tell you the formula of here m now. So the formula of m is like this. This is your x, total number of the your data points, sorry, n. Okay, this is going to be n multiply by summation of your xy, which you calculated here. This one. Okay, that's why we calculated it. And then you have the minus of this summation of x, then multiply by your summation of y. We will close it, divided by your again total number of the data points, multiply by summation of x square. Okay, and then minus summation of x, here this one. Okay, that's why we are calculating all these values, because you have done the square of the this one as well, product, and you did the square of standard deviation too, which you are going to use here, and this one too. So basically the formula for this one is m sum of product of deviation. This is, I have written the mathematical formula actually. For your understanding, why did we make this table? And then divided by sum of square of deviation for x. Okay. Now we can calculate the m value, sum of product of deviation. So what is that? This is the one, right? Sum of your product of deviation, this is 50. And what is the value of sum of square of deviation for x? You need to do the sum of this. This is going to be divide 50. So this is m value is 1. Okay. And now we will calculate the b. The formula for b, mathematical formula is this. Summation of y minus m multiplied by summation of x and this one, and then divided by total number of the data points. Or this is a maths formula. In actual, this is the one. In easy way, this is the one. Mean of y minus m multiplied by mean of x. Okay, so this is the same. Okay, now what is the mean of y? We have calculated here. This is the one, 250, right? Minus, what is the slope value of this one first? 1. Multiply by mean of x, this is 2.5. And when you calculated it, it is around 247.5. Okay, so this is the way. Now you have the value of y, you have the value of m, x, and b. This is the way how you are going to calculate the slope line value. Okay, now we can draw it here. Look at this. So this is your x, this is your y. So what is the value of your starting from minimum value? What was the area? 200K, right? Price. And then 300. We can make it up to like above, although we don't have these values, but this is just for your graph. This is number of room 2, 3, 4, 5, right? So your slope line, your m value is starting from 1, right? And then this is going to be 1. And what is the value of your b intercept? 247.5. This means we can start drawing from here around. Okay, so this is going to be start from this point. So what is the value of 2? Here 200 price. This is your first data point, which is already plotted. We have, this is 300, right? This is the 300. So it is somewhere around here. Okay, so this is the data point. Your the value when your, let me draw this again. This is the one and this one. So 3 and your 300 data point is somewhere around here. Okay, and this is going to be your m. This is the way how we can calculate the, by filling the all values of y, and you can draw the data point here. You have the two values. We have already plotted the data points here. This is the way how your model is going to plot the data points, and then it will try to fit the line which can cover up maximum your data points. Okay, this is the purpose of your linear regression. Now here I will tell you, I will then explain it after explaining this one more point. Here you have the data set of two houses, right? Tomorrow someone come to your house, they say, I have the 5 number of rooms. Can you predict the price? How much will be the price of the house? Then this is very easy for you now, right? You want to predict this value, you have the m value 1, right? He is telling you the room number of rooms of how many? 5. You have the b value 247.5, right? So it is going to be 5 plus 247.5. And when you will add it here, right? And this is going to be your, let's say 747 or something, right? Whatever value will come here, right? So we can assume your data points is somewhere, this is a 5, right? Is somewhere around here, above this value. Okay, so you can just predict it. This is your prediction because this is not actual value, right? You didn't knew the price, but you predicted it, and this is called the, in technical term, test data in machine learning world, where you are going to predict for what purpose you were making the model. This was your goal, because when you starting to train the model, you knew the answers, you know the prices, and you knew the like the number of rooms, so you plotted it here, right? But if someone tomorrow new data will come up, this is the number of rooms, this is a like your number of rooms, tell me the price of the house, because you have already trained the model using your previous data. Now you can predict because you have a value for each this one. Okay, and this is called linear regression. Okay, now the next most important thing is here, let me clear this up. The most important thing is here, another one is how you come to know which line is going to be the best for your variables. Okay, what will be the best slope line? Let me draw some data points here. So I am just picking up the random data points. Okay, here we go. Okay, so you can draw the line this way as well. Okay, but it doesn't mean it will always be like this way. Okay, maybe you try to draw the line this way as well, maybe this way. Okay, so there can be several lines, but you need to find out which one is the best, right? Which one is the best? Is this best? Number 2, number 3, number 4. Which line is best, right? So y is equals to mx plus b is to draw the your prediction, right? To like your data points. So this is you are calculating the data points only. But when you will draw the line, right, you need to like understand which line is going to be best for your model. So for this, what we do, I will tell you. For that, once you calculated your data points, you have plotted like, right, but you are done with your predictions, then you need to find out the errors too. Here we go. This is y, this is x. I will take a one line here. This is your actual data points which you already have in your data set. Okay. And let's suppose, right? And there are some like the data points you have predicted. Let's say this is the one. So we can make it like this. This is a prediction one. Okay. So you can understand the difference. This is new data, test data. Like I have given you the example. If someone come to your house, they will say you, I have a 5 number of bedroom house. What will be the price of that one? So you predicted it some price. This one, this one, this one. This is the new. But these were your actual points. Now you want to plot the best line, right? So in that case, you need to find out the difference between your actual and predicted one. This one. Okay, suppose its value is here, your this value is around, let's say predicted value of the price, actual price was the 200k, but what you predicted, that was 350k. So for this you will calculate the errors now. I will draw here 3 lines. So this is your actual value and this is predicted and this is error. Okay, so actual value is 200 and the predicted is 350. If you subtract them, 2 minus 350, it is going to be your 150, right? So this is your error. This means whatever your model is predicting, this is the 150, your more than the actual price. Okay, if it is close, we can consider this line best. If it is not, then we need to draw this line again. Okay, we will try to fit this slope line where you can cover up maximum your data points to, and it should be close to your predicted one too. Okay, now here if you look at the, you will calculate the errors for others value too, like this. Okay, it can be any value, and then you will make a list here. Let's say some around error here, somewhere around 50, somewhere around minus 40. It can be negative error too. Okay, here this is a negative error. Okay, so there are some values and result is this. So you will calculate, if larger the errors, then you will drop that line. Okay, because we want the less error. If smaller the error, then you will draw this line. If here you have some data points here, the predicted one. Let's draw here, right? This is close to your actual value. Maybe there are some data points, right? This is close to this one, and this is close to this one, this is close to this one, and it is from the bottom too. Okay, so there are two type of errors. This is positive error, this is negative error, because this is below the line. Okay, So this way you will try to find out the best line. When your error, we call it residual error 2. If less the error, good is the slope. Okay. So this was, I just wanted to share with you, like how to choose the your best line using the your this like this slope. Now what you have learned, mathematical equation y is equals to mx plus b. This is we use to point your data points, right? Predict the data points. You need to find the price of the house, right? Y is your price of the house and you are predicting it using the formula y is equals to mx plus b. You have learned how to calculate them, how to calculate the b. And then I have also given you the example when new test data will come up, how you are going to predict it. It's so easy, right? It's not so tough. It's very easy. As you have seen, I have tried to give you the most simplest example with the real time case. And then you also understood the formula. This is the same way you can also learn. Take a pen and the notebook, just draw the table about the formula and then just try to understand. Believe me, it will definitely help you to build a strong foundation in your machine learning journey. And the next your job was to how you are going come to know which line is best fit to your data points. In that you need to calculate the errors, the difference between actual and predicted one. Your model is only good if your predicted values are close to your actual value actually, right? If the price in your data set the price range of the house is between, let's say, 100k to your 500k, and this is the actual range, but your model is predicting above 500k, it is saying 800k. Okay, so in that case we call it outlier 2. Okay, and this is called residual error 2. So you need to like find out, although you don't need to do all these in the like the your python, because when you like use the inbuilt libraries it is going to be done itself. Okay, but only my goal is to make you understand how your model is working at the back end, how it is choosing the best slope or trend line or regression line which is fitting best on your data points. This was my goal. You are not going to do it using python, that will done automatically. Okay, that's why we handle the outliers. That is also important part of your machine learning. If you want to know like the about the outliers too, you can watch my playlist of machine learning. So I have made many videos on that. If you want to look for this one, I will show you just here. This is the all playlist. Let me open my this one, the playlist. Here we go. Okay, let me share my screen. Just give me 1 second. Here we go. Okay, so this is a all playlist. Okay, if you want to learn the statistics, you can watch this full playlist. Here I have made like mean, mode, median, Gaussian. I used to upload one video in a week or two videos in a week on the statistics, and this is the one. And if you want to learn about the handling missing values, this is the complete like your list is here. Okay, so here I also use the real-time use cases where students mostly found the problem in handling the missing value. This is the most important part too. And this is your statistics, and this is about your regression model. I used to upload every day one video on each topic. So keep watching, right? Keep patience and happy AI learning, happy coding. And believe me, just start using stat from today and just be strong and be expert in AI. This is the goal of science data science. Thank you so much. See you in the next video.